Okay. All right, so lecture 7, we have two packages, extra packages that we are going to look at today. The first package would be Ipwidgets. Yeah, the first package, as you can see here, Ipwidgets. The second package would be SciPy. Yeah, SciPy. Oops. Those are the two packages that we are going to look at today. All right, so of course you have to install. Okay, let's go through. The first is Ipwidgets. Right, so Ipwidgets, straight away I can just show you. Yeah, you get to create such a example. This is a slider, right? So the slider, we can drag the slider such a way that we can choose different values for x. So if we can choose different value for x, for example, you can create a function f to get the corresponding value. Okay, so we can create slider, we can create a drag drop. Yeah, you can create interactive plots. All right, so that is the purpose of Ipwidget. Okay, so that's a small, very short demo. All right, so what we can create? Ipwidgets can be used to create interactive sliders, drop downs, and text inputs. Okay, so basically very interactive. All right. We can, of course, you can combine whatever packages that you have learned so far. Okay, so in Ipwidget, we have a function called display, right? So once we set up the value, then we can display the slider or drop down menu. Okay, of course, if you just print it out, use the standard way you have been using all this while, this print function to print the output and etc. If you this time around, if you print out, you will not see the slider. So you need to display the slider instead of printing it. Okay, the first part, to install the package. To install the package, just uncomment this. Yeah, just remove the hash and you can just shift return. Okay, or you can always copy, create another one, another cell and run. Okay, when you run, of course, it will start downloading the package in your machine. Of course, mine I've installed already. Right, so please install that now. Once you have installed IP interactive Python widgets, you'd be able to run this cell now. Okay, in this cell, we are importing Ipwidget as widgets. This is, as you know, as widgets means just a short form. And then we're calling that short form with a function dot underscore underscore. This is a 2 underscore version. So my version IP interactive Python widget would be 8.1.7. Okay, this is my version. So once you can run this, which means you are now ready to use the package. Okay, so I hope everybody is like, yeah, everybody is following the notebook, yeah, Jupyter notebook. Right. In fact, today I updated a few things. So in case you have the old version, please download. Go to the eLearn and download. Get the latest version. Just slight changes. Okay. All right. Now let's make our first slider. Okay. The first slider. So we're going to import actually two packages. The first package should be import Ipwidgets as widgets, and then interactive Python ipython.display import display. Okay, so this is an important function that we are going to use to display the slider, the drop down menu, and etc. Okay, all right. Okay, now this is a slider. Okay, so we're going to create a slider, and then the slider, to create the slider, we call widgets.float slider. Yeah, the float slider is the slider that you see below here. Okay, and the float slider, in the argument, there's a long with things, long components in there. The first is the value. Okay, so if you run, okay, it starts with value 1. So this is the first one here, the default value that you want the slider to start with. Okay, that's the first one, default value. And then the minimum value, maximum value that you want the slider to hold. And then the step size, every single time you drop, the minimum unit is 0.1. Okay, and the description. And continuous update simply means that as you drag, you want to see the value of X. Okay, so and then that's about it. Yeah, that's about it. That's a slider. Okay, and then display slider. When I display slider, you would see this button already. And then of course, whatever that is that we set in the argument, right? And then, as I said, we can't use print slider, but we are not printing out the outcome here. Rather, we want to display the slider. So if you print out slider, the output is in fact this float slider. Okay, so we don't want to use this. Rather, we will use display slider only. Yeah. This is just to show you what would happen if you try to print the slider. Okay, so you can just comment that out. So we just use display slider. Okay, okay. So this is our first slider. Okay, next we're going to use the interactive function. Of course, the interactive functions is also in Ipwidget. Yeah, interactive function. Okay, here the interactive function we can use for various kind of things. Yeah, here just to print out the outcome, the corresponding value, for example. Okay, so first what I did here is I created a simple function. Yeah, simple function fx. The name of the function is f. The input is x, and the output would be, it will just print out. As you can see, it is just print out. It is, I should say, to be specific, I should say it is a procedure. A procedure has no, oops, a procedure has no, oops, has no return. You don't see return statement here, whereas a function has a return statement. A function will return something to you. Here, we just want to visually see it, right? Visually see it, visually let the student be interactive. They can just like drag and see what is the outcome like. Okay, so since that is the case, we're just displaying the outcome on the screen. We are not going to return something to do further computation. So that's why there's no return function. So it is just a procedure. Okay, so def f, yeah, f is a mathematical function which would return x. No, I shouldn't say return, which would print out x squared. So as I drag the slider, the output that is displayed here is just x squared, which is the f function. So how to write? So once you have the function, of course, first you need to write the function. Once you have the function, you're going to call this interactive function. That is interactive function, which is in Ipwidget. The first argument would be the function itself, the definition, the procedure. Yeah, I should say the procedure, def fx. Of course, you just call it as f. And the input, next is the input or the argument for f, which is now I define from 0 to 10. Okay, and display w. So when we display w, basically the slider, as I drag, the slider is taking the value of x and running this this procedure, right? This procedure is just one line, one-liner. Okay, yeah, so it just prints out f squared is whatever the x value that it holds. Okay, okay, so a simple usage of interactive function from Ipwidget. Okay, so we can also use interactive function from Ipwidget to do interactive plot. Previously, we learned how to use Plotly to do interactive plot where you can zoom in, zoom out, pan, and etc. So this time around, we can actually create whatever that you see in interactive plot your own using Matplotlib, okay, with the help of interactive Ipwidget function. Okay, so again, we need to use the display function as well. So this two lines comes together because at the end of the day we need to display the outcome, right? The rest, the first two line, import numpy and import matplotlib, is just to run matplotlib and create the data and the function, right? Okay, so again, you see this is a def, yeah, a procedure from here until this line here, until plot dot show is actually a procedure with a no return statement. Okay, so the first two line in, of course, this is the name of the procedure. The procedure takes a value a. Since the procedure takes a value a, so a is the value that we are going to control in the slider. Okay, so this a, yeah, this a that you see is in fact in here, in which we would be able to drag to get the corresponding plot. What is the plot? The plot, the plot's procedure's name is plot underscore quadratic. And what it does, so it takes the x value. X is defined from -5 to 5. And then the y value, the plot that we are going to create, has a coefficient a. And then times x squared. So basically, a is the value that we are going to interactively control, such a way to see how the plot is changing. Okay, so the rest, plot figure, PLT plot, this is AX horizontal plot, AX vertical plot, right? This is the X limit and this is the Y limit. This is a plot legend, a plot title, X label, Y label, and grid true. And then finally plot show. So the rest are matplotlib's function. Okay, so when you run, okay, so maybe of course now we use interactive, the so-called a procedure which we named as plot underscore quadratic as the first argument, and the next is the value of a, which is the coefficient for y, to control to get different kind of plot. Okay, so this is the, okay, so a starts from 0. So as you can see, as we drag a, right, so the plot changes interactively. Okay, so this is how you can investigate your plot further by controlling a particular variable, which is now beyond Plotly. So in Plotly, you can't do this. Rather, what you learn is that you didn't learn creating dashboard. With Plotly, we can actually create dashboard as well. Okay, so of course, a dashboard means more interactivity, right? So here, a simple interactive plot with Ipwidget. Okay, next example. Again, we are using interactive plot, but this time around we are creating a surface. Again, the whole surface is built using Matplotlib. Yeah, for Matplotlib, for 3D plot, we have to bring in this function here, yeah, mpl underscore toolkit dot mplot3d. Okay, so we're bringing in as axis 3D. Okay, this is should not be something that is new. We have done this in our previous lecture. Okay, all right. Let's look at the first line. Yeah, the first line here. Def Gaussian underscore surface. That's the name of the procedure for this plot, and sigma equals to 1.0. So sigma is actually the distribution plot, a normal distribution. Sigma very much controls the, how should I say, the thickness. Yeah, the thickness. So this is a 3D distribution plot, 3D normal distribution plot, which is a Gaussian distribution. So sigma is in fact the standard deviation, right? Okay. All right. So when I equate here sigma equals to 1.0, what it means is that when you run by default, sigma will be set to, sigma will be set to 1. Okay, so you can just put in here sigma equals to 1.0. What it would do is that it by default, when the first time you run it, it will start with sigma 1.0. Okay, so that's the first line. Okay, so next line x, so we are creating x values, y values, and then we are creating the net and pushing the net into this equation to create the corresponding z values until the end. This is the Gaussian distribution function. All right, and the rest are matplotlib's function. Yeah, that's our matplotlib's function to plot this 3D shape, which is a Gaussian surface. Okay, so it's a simple example. Okay, then yet another example for 2D plot. So this time around, last two example, we only had one variable to control by sliding the slider. This time around, we have 4. So how to create those 4? As you can see, first is the function. Next are the so-called the variables that you want to control. So the variables you want to control, you basically put it just by adding comma and then keep on adding all these variables. Of course, before you add here, you have to introduce those variables in your function. Okay, the functions are, let's say here, there's so-called two functions. Target y, yeah, and then another y inside here. Okay, so target y will be directly drawn. Yeah, target y is directly drawn here, whereas just y here is the function that is being plotted with this equation. And in this equation, we have a number of variables, free variables, a1, f1, a2, and f2. So the idea is that we want to create a plot such a way that students get to interactively like pull this and push this, and like the question would be try to find the values a1, f1, a2, f2 such a way that it would approximate the original curve. Okay, so the target for curve would be the y dash rate in red color, and then the blue is the curve that you are asking the student to uh, to drag such a way they get to find the right answer. Okay, so just a simple like a game, such a way that they get to see how the function takes in all these values and the curve changes accordingly. Okay, the answer is here actually. So if you choose this answer as such, you would see that the blue curve is in fact exactly would be the same as the red curve. Okay, the answer is here. A simple simple, again, simple idea for the students to be, to be interactive, get involved in teaching and learning. Okay, next is drop down. So far we did interactive, right? We just tried to like just a slider. So this time around we do drop down. Drop down is, this is what is drop down is all about. Yeah, see, you get like, for example, here you have two choices. I create two type of functions in which students get to choose those two choices, and then they, of course, we add a slider as well. We can slide and then evaluate the function on top here. Okay. All right. So how to do that? The same thing, but this time around we bring in drop down function from Ipwidget. Not just interactive, but drop down as well. And of course, we need the display function from ipython.display. NumPy is basically to create a function. Okay, so I'm going to create two functions which are going to be available for the student to choose in drop down. So the first function is called square. The next function is called square root. Okay, sqrt. And then, of course, here there's a return. As you can see, there's a return function. Okay, so we get to see the outcome. You can also change these to just print, because we are not doing any kind of computation after that actually. So if you want to change it to just print x squared, is also fine, right? But here we are just we're going to return. We're going to use that later. Okay. Next is creating that drop down, right? First, is it def evaluate the input with the function and the argument x. So if, okay, so we have, how many you have? Here we have only two. So if and else nested statement is sufficient. If you have three, then you're going to use if, elif, else, right? So the first choice in drop down will be called square. Next is actually square root, yeah, which is written here actually. One is square, the other one is square root. Okay, of course the result would be square x, which is the function that you wrote on top here. Okay, we are breaking into small pieces, right? You can also actually, in fact, you can just like take the whole thing, just put it here as well. Yeah, that's also possible. But writing in this way, you would be able to modularize it such a way like, okay, small part does small things, right? So you then put them together like a putting a Lego set, right? So square x here, actually calling this function, right? And similarly, square root, it's calling the function square root here. Okay. Okay. Then of course, finally, when it knows which one to choose, once the student chooses either square or square root, finally it goes out from that if statement and it will print out the outcome. Okay, the function and the results. Right. So once you have your function, evaluate function, then we create interactive slider. Okay. So the evaluate is for the student to choose. Interactive is for the slider. Okay. So for interactive, the input will be evaluate, which is now in the form of drop down. See, evaluate function name is drop down. Of course, in drop down, we have number of arguments. First is option. On top, you saw two options. If you have three, then it's going to be three here. So two options in a list. The first element in the list is the first option, then followed by the second option. Now value equals to a square. This is the default. When you run, it will run, you'll see square here. So that is the value. Okay, if you change to square root, then it will change to square root, being the default outcome when you run. Okay, finally, this description equals to function. Okay, and that's all, right? So when you run and you choose the X here, right? So we have interactive, evaluate, function from here to here, and then finally in the interactive would be the X values, just like what you saw earlier for the slider, right? The original slider had a function and X values. This time around, we have a drop down in the middle. Okay, the content in the drop down is option, value, and description. Okay, so the description is responds to the name here that you want to, of course, you want to give a label to what they can choose. Okay, so they get to choose and then drag, choose and drag. Of course, you can convert this rather than having to see the value. You can always see the plot. Okay, that is the next one. Yep. Okay, so this time around, plot function rather than just evaluating. And in the middle would be the drop down component, and finally the X value. So the plot function, what it does is this. Yeah, this is the whole plot function. So we have two plot function. Yeah, if function name is squared, it does square. Otherwise, it does square root. Okay. Okay, so the user get to choose and also drag. Get to choose the function, also drag. So this is just an example. So of course, you can think of different ways, different modules for a project to develop, and let it be as interactive as possible for the students to learn. Okay. So that would be the first part of lecture.